Welcome all. In this session, we are going to solve a problem titled as valid parenthesis. Let's try to understand the problem statement. You are given a string that is made up of only the brackets of different kinds. For example, there is a bracket of this kind, curly brackets, square brackets. So the characters inside the given string will be only made up of these brackets, and we have to check whether that string is valid or not. So how can we check this validity? So as you know, whenever we are going to solve a mathematical expression, it is essential that a bracket is closed properly, and the validity of the string here is also something but very similar. For example, I can give you examples of how a string is valid or not. If you take the string something like this is valid because there is an opening and a closing. And let's take another example. Here, this is also valid because there is an opening and then there is an opening, closing, and opening, closing. And let's take another example. Here there is an opening and closing, but it is not valid because the opening and closing brackets are of different kinds. So this is not valid. So let's take another example. So how can we check the validity of this thing? Here, this is valid because whenever there is an opening curly bracket or an opening square brackets, so it is getting closed in a sequential order. Like this is closed internally and remaining thing is also closed internally. And we can check another example. If instead of this, if it's something like this, this is not valid because if we want to close this particular brackets, in the middle there should not be anything. Similarly, if you want to close down the square brackets, in the middle there should not be anything. So once this is closed, it is went from there, then it's remaining. So intuitively, this is just like a mathematical structuring of expressions. So that's how we are going to understand this problem. So how can we solve it? To solve this problem, we can use the concept of stacked data structure. So in the stacked data structure, what we are going to do, since we just add something here, above and above, in stacked data structure, whatever the last input elements, that will go out. First it will go out. So the logic to solve the problem is that whenever we encounter a opening bracket like this or this, we are going to stack, we are going to save it in the list. And whenever something else, something other than this particular bracket comes out, what we will do, we will check whether, like, first of all, whether the stack is empty or not. If it is not empty, if it is empty, that means the expression is not going to get validated, because it has to be, whenever this kind of bracket comes in the expression, as we iterate, the stack should have this particular bracket immediately, like that. It should not be something like this. Immediately it should have there, then only it will be validated. So we can just say, take this example and see, this came, we stored it in there. So how we are going to stacked up below, stacked up here. When this came, when I am going to pop it from the stack, this is what popping up. That means we cannot like compare or collate both of them, so that means this is not valid. But if this was the case, so this is stacked below, this is above, and when this came, we can pop this thing. Okay, this both will collate, that's fine. When the next one came, this one will be the one to pop up, this also collate very well. So that's the logic. So for that we are going to use stack data structure. I hope you understand. But once we are coding, it will be much more clearer. So let's try to code it. So let's try the class expression, class solution. What is the method inside the class is valid. Let's try to write the arguments by self. This is a string, and what we are expecting is boolean. Now this is how we are going to define the stack. Basically this is a list. Now let's store. Before storing, let's iterate. For ch character in s, if ch equal to this opening type of bracket, or ch equal to opening curly brackets, or ch equal to the square type of opening brackets, if any of this comes, we have to append stack dot append ch. If it's not that case, if it's something counterpart to that case, then else case, first we need to see whether the stack is empty or not. Like if not stack, by doing this we can check that. If that's the case, it is not valid. That means this is not a proper expression. Return false. And if ch equal to this closing bracket, and at this case the counterpart, which is the end of this particular stack, should be this one. So if it's not that case, we should return false. So that should be wrote here. And stack dot pop not equal to this particular bracket, then it will be return false. Similarly, this applies for the other two types of brackets also. So if ch equal to curly closing bracket and stack dot pop means removing from the end, not equal to this curly bracket, return false. If ch equal to square bracket and stack dot pop not equal to the opening square bracket, return false. And once this is iterated and completed, and that moment we can say like whether the string is valid or not, like return true if length of stack equal to 0, else -1 or false. This is how we are going to check. I hope you understood. It can, if you think about it for a moment, you will also understand what exactly is happening here. So what is the time complexity here? So the time complexity here is that we are iterating only once, that is order of n. What is space complexity? So to implement stack using list, we have used an extra list, so that is on. So this is a simple problem. I hope you understood. You can write it by yourself, and I'm sure you will also understand this particular problem. So thank you for listening.